Did you know that you can use data about a planet's satellite to predict the mass of that planet? In today's video, I'm going to show you the formula that allows you to do that. The formula that shows the relationship between the mass of a planet and the distance as well as the revolution time of a satellite orbiting that planet is as follows. M sub p equals 4 pi squared r cubed divided by g times t squared. M sub p is the mass of a planet. R equals the distance between that planet and its satellite. G is a constant equal to 6.67 times 10 to the minus 11 Nm squared per kilogram squared. This is Newton meters squared per kilogram squared. And finally, the last value is T. T is the revolution time, which means the amount of time it takes a satellite to make one full trip around the planet in its orbit. Now, using data from the moon Io, I can predict the mass of the planet Jupiter, which I'm going to note as MPJ for massive planet Jupiter. So according to this formula, I would put in the radius, the distance between Io from Jupiter, which is 422 times 10 to the 6th meters. I'm going to cube that value and divide all of this by G, which I've noted above, and t squared. T in the case of the moon Io is 152,928 seconds. In this particular equation, you must place the revolution time in seconds. When you do the math, you get 1.9 times 10 to the 27 kilograms as the mass for the planet Jupiter. As a way of verifying this, you can then do this same formula using data from a different satellite of the planet Jupiter. So if you use the data for Ganymede, another one of Jupiter's moons, in which its mean distance is 1,070 times 10 to the 6 meters, you then cube that, you divide that by g times its revolution time squared, which is 618,624 seconds, you will again get 1.9 times 10 to the 27th kilograms. So visually speaking, this basically looks like the following. Here's the planet with its mass m sub p. The distance between that and its satellite is r, and the amount of time that it takes this satellite to go all the way about the planet one time is t. So using data from other moons of the planet Jupiter, you will be able to confirm that this formula, m sub p equals 4 pi squared r cubed divided by g times t squared, does in fact work.